Alright, so let's do long division like way back in the day. Yes, we definitely could put this in our calculator and we would get our answer. The bad thing about polynomial division is the calculator doesn't really help us. We can't put a polynomial in the calculator and divide out another polynomial. Our calculators just aren't that smart. So if you think way, way, way back, I don't know what grade you learned this in, like 4th, 5th grade, but we did something called long division. You would draw this L, that's upside down. Your dividend is this big number in front, the number that you're dividing out of. So 1,206. And then what you're dividing by, 9, goes out in the front. Okay, does this look familiar a little bit? Okay, so if we can do this, then everyone in here can divide polynomials because it's exactly the same. The same ideas, the same process. The only difference is we're going to have some x's and exponents. Okay, so what our mind is doing is we think to ourselves, can I fit a 9 into a 1? No, right? 9 can't fit into 1. If a car has only one seat, 9 people can't fit into that car, can it? Okay, so then we look at our first two numbers. Okay, can 9 fit into 12? Yeah, how many 9s can fit into 12? Only 1, because if we did 2, we would go over. So we can fit 1 9 into 12. And see how I put the 1 above the 2? I didn't put the 1 above the 1 because I'm looking at 12 and I want to put it at the end. Okay? So I know 1 9 will fit into 12. So the next thing we always do is we would multiply. 1 times 9 is 9. So you write it under the 12 and then subtract. 12 minus 9 gives us 3. Okay, 9 can't fit into 3, so we need to bring down our next digit, the 0. So now we're trying to figure out what number is going to go above the 0. Okay, so again, we are going to go through the same process. How many 9s can I get to fit into 30 without going over? 3. I can fit 3 9s into 30. Okay, to figure out what to subtract by, we multiply 3 times the number out front. 9 is 27. And I subtract. 30 minus 27 is 3. And we have one more number to bring down. We bring down the 6. How many 9s can fit into 36? 4 exactly. 9, 18, 27, 36. 4. And then we multiply. 4 times 9 is 36. And when I subtract 36 by 36, I get 0. So 9 goes into 1,206 exactly 134 times because we have a remainder of 0. This is long division. Now, we probably haven't done it in a long time because in most of our classes, we would just put this in our calculator. Okay? But this process is exactly the same. Okay? You're trying to figure out how to fit it in, how many is going to fit in. You multiply, subtract. You can just keep doing that over and over again until we get to the end. So let's take a look at how this will apply to an actual problem. So here's our first example. And we are going to use long division in order to divide these two. So the first thing we need to do is set it up. So just like before, we draw this upside down L. I'm probably going to do it off to the side here. This upside down L. My big polynomial, called the dividend, goes on the inside. Y squared.
Should it be 1y squared?
Yeah, we can put a 1 in. If you want to put your invisible ones, you can do that. Plus 3y plus 2. And what I'm dividing by, y plus 1, is going to go out in front. Y plus 1. Okay, now bear with me. The first one is always the hardest to get through, but it will click. We're going to, hopefully it clicks today. It might take a few though. Again, if you want to put your invisible 1 in front of the 1y, you are welcome to do so. So, how many terms does 1y plus 1 have? 2. Okay? So just like we did in that long division, remember the 9 couldn't fit into a 1, so we had to look at the first 2 numbers, right? And then we were like, oh, 9 can fit into 12 one time. So same thing here. 1y plus 1 has 2 terms, and you can't fit 2 terms into 1 term. You can't fit a 1y plus 1 into just 1y squared. Okay? So we have to look at the first 2 terms. We're trying to figure out how many times can 1y plus 1 fit into 1y squared plus 3y. Now here's the trick. Here's what your brain has to constantly be thinking about. You always want to look at the very first term. Whatever's in the front. Wherever you're at, you want to look at what's in the front. Your goal is to figure out how to turn 1y into 1y squared. So here's what you're going to do. You're going to think. I know, trust me, it should not make sense yet. It'll click eventually. What would I multiply my red 1 by to get 1? 1. So we know that we have to have a 1 up here. And again, see how I put it above the second one? Because we're looking at the first 2. Okay, and now the tricky part. I have a y. I need it to be a y squared. What is it missing? It's missing a square. This term only has a single, it's just a y. What can I multiply y by to make it y squared? Y. So I need 1y. Now this is what's really hard. You got to wrap your mind around. 1y plus 1 fits into 1y squared plus 3y 1y times. Okay, just like 9 fit into 12 how many times? Once. If we multiply, because remember now we got to multiply and rewrite it underneath, we want this first term to go away. Okay, so after we have found what goes on top, we picked this term because it's going to make this 1y a 1y squared, and when I subtract, it'll cancel out. Okay, so my next step is to multiply. What is 1y times 1y? 1y squared. Oh no, my board was doing this yesterday. 1y squared. Okay, and this is what we want to happen. These first terms always need to cancel out. If they're not canceling out, or not exactly the same, then you pick the wrong term for the top. Okay, now I can't just multiply 1y by 1y. What do I also have to multiply it by?
1.
The 1. Okay, you can't just multiply half of this by 1y, you have to multiply the whole thing. 1y times 1 gives me 1y plus 1y. Okay. So what have we done so far? We figured out how many times it fits into the first 2 terms. It fits in 1y times. And then we take that term and we multiply it. And if you look back to that long division problem we did, then we subtract. Okay, now parentheses are very important here. You're going to put parentheses around it. And you're going to put a minus out front. we're going to subtract. 1y squared minus 1y squared is 0. That's what we want. We want to cancel terms out one at a time. Those cancel. It's gone. What is here's tricky. This is where kids get messed up. They try to do 3 plus 1, but it's not 3 plus 1. It's 3 minus 1. 3y minus 1y is 2y. Please don't do me like that. 2y. Now, what did we do in the long division after we subtracted? What did we have to do? Drop the next term. Okay, because 1y plus 1 isn't going to fit into 2y. We need another term, so we drop the next one down. I don't understand. I think this pen is running out of battery.
Yeah.
Isn't there a way to like charge that thing?
We have a charger, but I don't have another battery. We can run next door and steal one.
They have them in across the hall?
They have them like next to Tuff. Go to Tuff's and just steal a battery. Okay, so now we're going to do it again. Bear with this pen because it's this last limb. This is now our new front term. So we need to figure out what do I have to multiply 1y by in order to turn it into 2y. What do I have to multiply 1y by to make it 2y? Yeah? 2. Okay? We just need to multiply it by 2. A positive.
It's not fighting. Just take it. The whole thing.
Yeah, that one seemed better day. We need to multiply it by a positive 2. Yep, that was the issue.
Where's
So,
the charger at?
oh, I have no idea. It's around, but okay. So we just multiply by 2 because the y's already match. We don't need to multiply by an extra y. We just need to multiply by 2. So now we start multiplying. 2 times 1y is, and 2 times 1 is 2. And now look, what's going to happen when I subtract these? Yeah, 2y minus 2y is 0. 2 minus 2 is also 0. So what's our remainder? 0 is our remainder. Our answer then is what we get on top. The answer to this, y squared plus 3y plus 2 divided by y plus 1 is 1y plus 2, or just y plus 2. Okay, there's your first problem of division. Again, I do not expect it to click yet. Maybe it did. It takes a while, but it'll click. Kind of weird, right? Alright, let's do another. We'll go nice and slow. Ask questions if you have them. Okay, here's another one.
So y plus 2 is the answer for the first?
Y plus 2 is the answer. And actually what's interesting is, do you know how you could check your answer? If y squared plus 3y plus 2 divided by y plus 1 is y plus 2, what could I do with y plus 2 and y plus 1 to check?
Divide.
Not divide them, I could multiply them. If you did the box method with y plus 2 and y plus 1, guess what you'd end up with? Y squared plus 3y plus 2. Okay? Because they're opposite operations. Okay, just like, 12 divided by 2 is 6, right? And if you could check by doing 6 times 2 brings you back to 12. You can do the same thing. Yeah, let's do it again. Okay, let's set it up. Draw your upside down L. An L I kicked over on its side. We got our x squared plus 3x minus 4 on the inside. And we have x minus 1 on the outside. And if you are someone that likes your invisible ones, you can always put those in. There's a lot of stuff always going on in these problems, but you are mostly focused on this very front term. These two terms in the front. You're trying to figure out, what do I need to multiply 1x by to turn it into 1x squared? 1 times what gives me the 1? Yep, just 1. 1 times 1 gives me 1. But I only have 1x here. So what would I multiply x by to make it x squared? An x. It needs another x. And look at this pattern. If you look back to the last example too, when you look down your, the rows, look at x, y squareds all line up. What all line up right here? All y's, and here, all normal numbers. Your variables and stuff always line up. As long as you start your first term on the second spot, look, our x's will all line up, our x squareds will line up, those terms stay nice and lined up. So if you're having a hard time figuring out, I don't know if I multiply by an x or an x squared, just look underneath it, they'll line up. Okay. So after we have that 1x up there, what do I need to do with it? Multiply it. 1x times 1x gives me 1x squared, and that's when you're like, okay, good, I picked the right thing, because these should be the same so that they cancel out when we subtract. And then I multiply 1x by negative 1, and I get negative 1x. And now I'm going to subtract. Of all the places to make mistakes in these problems, students do an amazing job of finding what to multiply by, that's the hardest part. Finding those numbers up top, that's tricky. But the biggest mistake we see happens right here, when they subtract. Here's why. 1x squared minus 1x squared, of course, is 0. We want those to cancel out. And here's where the mistake goes wrong. What do you think most people write down for 3x minus negative 1x? 2x. Most people, even me, I will make the mistake too. You'll have to keep an eye on me. Even when I do, a lot of times we just want to do, 3 minus 1 is 2, but it's not 2. Because we have to do 3x minus a negative 1. 3x minus a negative 1 is not 2, it is 4x. Yep. You see how people would make a mistake there? I totally get it. Your eyes like to look right here and just subtract, but don't forget, we're subtracting these. 3 minus negative 1. Okay? I can't fit 1x minus 1 into 4x, so what do I need? I need to drop down my minus 4. Now, instead of looking at the 1x squared, we got rid of it. The new term that I'm trying to get rid of is 4x. So you're trying to figure out, what can I multiply 1x by to turn it into a 4x? A positive 4. And you can see that pattern is still happening. The next spot where I'll write my next number, there's no x there, so I just need a plus 4. Okay, if I add any extra x's to this 4, then it's not going to be just an x anymore. Okay, now it is time to multiply. 4 times 1x 4 times negative 1. Love when this happens. When we subtract these, 4x minus 4x is 0. Negative 4 minus negative 4 is 0. We have a remainder of 0. So our answer is x plus 4. Or 1x plus 4. How we doing? Is it starting to make sense as we do more? Alright. What do we got next? Okay, I'm gonna let you guys do it a little more this time. Okay, first thing I want you to do is set it up. Take a minute or two and set it up. Draw your little L that's fallen over. Put everything in there. Yep, that's good. Okay, so you should have put your k plus 4 on the outside. And your k squared plus 14k plus 40 on the inside. Yeah? This is what everyone's looks like? Hopefully. Okay. Again, if you like your invisible ones, feel free to put those in. It won't change your answer. So we're trying to turn 1k into what? 1k squared. So write down above your second term, because we need to fit it into two things, so we write it above our second term. We know we need to multiply 1 times 1. And now look, if you're confused about the k, this is how easy it is. You look right below it. What variable's below it? Just a k, right? Which means the 1 needs a k. The reason it's k, we need a k, is because we need to do k times k to get k squared. But if you write your number up top and just look below it, it's going to be that same variable. Okay, and now we multiply, which I didn't really mention, but why do we multiply both things? Which property is that? Like if I'm multiplying 1k plus 4 by 1k, I have to do the distributive property. That's why we multiply both things. So 1k times 1k is the 1k squared. 1k times 4 is my 4k. Okay. Now subtract. You got it. Subtract, subtract, subtract. Alright. What happened to those 1k squareds? Canceled. So we subtract 14 minus 4 and you got 10k. Beautiful. Okay, what'd you do next? Drop down the 40. Were you guys able to figure out what to multiply 1k by to turn it into 10k? multiply by 10. So where are we going to write that 10? Plus 10 on the end, above the 40. And again, your variables should always be nice and lined up. I got my k squareds in my first column. My second column, I got all k's. My last column, I got all normal numbers. Okay, so go ahead and multiply 1k plus 4 by that 10 you just wrote up top. Okay, so we got 10 times 1k, gave me 10k. 10 times 4 gave me 40. And subtract. 10k minus 10k cancels. 40 minus 40 cancels. So I have a remainder of 0. So my answer is k plus 10. K plus 10. Alright, we got one last one to do together, yeah? One last problem to do together. Okay, a little bit longer. Okay, setup is exactly the same. Draw your L. Okay, there it is all set up. Okay, now, yeah, it's definitely a little bit longer, but our process is still exactly the same. You are focusing on your first two terms, remember, and if you like those invisible ones, go ahead and write them in. Now, I'm looking at the first two terms. Okay, so the first place I'm going to write is above the second term. So what will I have to multiply 1a by to make it 13a squared? 13, what's my variable going to be? A squared. Which makes sense, because when I multiply a squared by a, it will become a to the third. Okay, but again, if you don't like the whole variable thing, if you look at what's underneath, it's basically telling you what variable you're supposed to put. There's an a squared underneath, which tells us that we need to multiply the a squared. Okay, so now we multiply 13a squared times 1a. Oh, why am I writing a 13? Why didn't you guys tell me I'm crazy? Should there have been a 13 there? No, it's just 1a squared, right? My fault, my fault. I was like looking at the 13 and just copied it down. Right? We just need it to be 1. 1 times 1 is 1, not 13. 1 times 1 is 1. A squared times a gives me the a to the third. Okay, so that gives me 1a to the third. And then I have to multiply 1a squared times 6 gives me 6a squared. And again, there's our exponents all starting to line up. And we subtract. My first terms, boom, canceled. 1a to the third minus 1a to the third, 0. Second term, 13 minus 6 is 7a squared. And then I need to do what? Drop down your next term, right? We need two terms. We can't fit two things into one thing. We need to bring down a second term. Okay, my new term I'm focusing on getting rid of is the one in front. So 7a squared, that's what's got to go next. What will I multiply 1a by to turn it into 7a squared? Yeah, I like to break it down and be like, okay, before I deal with my a's, what do I multiply 1 by to get 7? Well, I definitely need to have a 7. And then you can either just look right underneath and be like, oh, it needs an a, so it matches up. Or you can think, I have an a, I need an a squared, so I need one more a. Okay, but your variables do match up down the columns. And now we multiply everything by 7a. 7a times 1a is my 7a squared. 7a times 6 is positive 42a. Right? All good? Time to subtract. My 7a squareds cancel each other out, and I just need to subtract. 39 minus 42 is negative 3a. And bring down minus 18. Last but not least, the last thing I have to eliminate is I need to eliminate negative 3a. What can I multiply 1a by to make it negative 3a? Negative 3. Negative 3 times 1 is negative 3. 1a already has an a, so I don't need to put any extra a's up top, but I can always just look below and be like, oh, this is my constant, so no a on the top. So, multiply negative 3.
Good morning, Tiger Nation. Today is Thursday, January 26th, and these are your morning announcements.
Multiply.
There will be no school January 30th. School will resume on January 31st.
And
enjoy your long weekends.
Wait, there's no
Are you
school
interested
what?
in being part of the Creative Community Art? Join us every Thursday, starting the 26th for Art Club. Meetings will be held in room 352. See Mrs. Kluger for more information.
And what's our remainder?
0.
Thursday,
Tiger Nation.
So our final answer for this last example is up on the top, a squared plus 7a minus 3. And there we go.